So if we simplify this one, what comes out? This will be 4. This will be negative root 2. So 7 minus 4 is 3. So we shall have this one as 3 minus root 2. The corresponding value, why is that? When you simplify this one, the 2 will multiply each value in the bracket. 2 times 2 will become negative 4. So 7 minus 4 is positive 3. Then negative 2 times root 2 out of 2, the 2 will cancel, remaining on a negative root 2, which is this one. And for x being equal to 2 minus root 2 out of 2, the corresponding y will be 7 minus, the 7 minus is this one, minus 2 into bracket 2 minus root 2 out of 2. And when we simplify, then this is 4, so 7 minus 4 is 3. Now here we have negative root 2 times negative root 2 out of 2. The negative will cancel and even the 2 will cancel. This will be a plus. Those are the two answers. When x is this, y is this. When x is this, y is this. So I'll be seeing more application of indices. So indices can be applied in and no any one time shall the question tell you using the indices do this. No. We'll just tell you. So I'll just give you the question. It is you to identify whether you have to use indices or you don't have to. Are we together?
Sure. I realized my mistake.
All right. So we now want to start a new topic, logarithms. 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 We are done with the indices, we are done with the studies. Now logarithms. Someone is saying, why don't you calculate the root 2 and you complete it? No. The topic is studies, logarithms, and indices. So where we can use studies is okay. Where we use indices, fine. Where we use logarithms, no problem. Now, logarithms. Who can tell us anything about logarithms? What do you know about logarithms? Anyone to tell us what you know about logarithms? You covered them in O level. What did they say a logarithm is?
So I don't remember the definition.
Yeah. That at this time or at this level, it will be very important to know the definition. Very important. Because all the laws, when we are proving them and what we shall be used quoting the definition. If I can from here, what do we know about 10 power 2? This one is equal to 1. What is 10 power 2? You want me to say 10 squared? When I say 10 power 2, you think you don't know it. Okay, what is 10 squared?
100.
It's 100. What about 2 power 4? Two power 4?
16.
16. Now, this one means if I raise the number 10 to the logarithm, to the index 2, or when I raise 10 to the power 2, I get 100. That means the logarithm to the base 10 of 100 is 2. Can we relate those two statements? If 10 power 2 is 100, then the logarithm of 10, the logarithm of 100 to the base 10 is 2. That's how we read that statement. The logarithm of 100 to the base 10 is 2. Just like here, I can say the base is 2, the power is 4, and the number is 16. It means the logarithm of this number to the base of 2 is 4. The logarithm of 16 to the base of 2 is 4. Does it make meaning? Oh, sorry. Do those statements make meaning?
Yes, teacher.
I want our lesson to be interactive. It is better.
Teacher, it's not.
It's not.
Teacher, please explain again.
I started with what is 10 power 2? 10 power 2, you said it is 100. Now, one person can read this statement.
100.
One person can read it as 10 raised to the power of 2 gives 100. Now, we are saying another person can read the same statement differently by saying the logarithm of 100 to the base 10 is 2. Meaning, if you find someone having written something like this, if I say it's logarithm of A, logarithm of B base A is equal to C. If you find that statement and I say, write it in the format 10 squared is equal to 2 into 100. What will it be meaning? It means that when I raise A to the power C, the answer will be B. Just like here we said, this one is the same as logarithm of 100 to the base of 10 is 2. Can we relate this statement to this one? And therefore, you tell me how I have to write this one in the format this. If I have to write this one to extract this format from this, how will it be written? A power C. Is it the case? And we write this one in the form 10 squared is equal to 100. Remember, this one has come from this. if we get in terms of ABC, how shall we write some things in the format of this one so that it matches with? You can use matching. Here the 10 was the base. Our base in this case is 8. The 10, which is the base. The 100 is what is the other side. So we are saying this one is equal to the 100. What is the power of the 10 here? Is what is on the right hand side of the side. What is the power here? Is B. It is what is on the other side. So this is B. What was beyond the equal sign becomes the power. What is beyond the equal sign becomes the power. So this statement means that A to the power C is equal to B. Let me write this definition here. Probably it will be much easier. If we understand this starting definition, all what we are going to do is going to be quite simpler, because the number of derivations we shall make, and we shall be quoting the definition. We are saying that the logarithm of a positive number n to any given base, any given base. Maybe the base we can use A. To any given base is defined as the index. Defined as the index or the power which A is raised, to make it equal to the given quantity n. i.e., if A is raised to the power x to give n, then x is the logarithm of n base A. And it is written as log. The base is written down and that statement is very, very important. It's important that we understand that definition. So what we call the logarithm of a positive number n to any given base a is defined as the index or the power which a is raised to make it equal to the given quantity. For example, if a is raised to the power x so that it is equal to n, then we can say the logarithm of n to base a is x. Does that statement make meaning?
Yes, teacher.
That's why we are using the other examples. That 10 must be raised to the power of 2 if it is b equal to 100. It implies that the logarithm of 100 to the base of 10 is 2. The logarithm of 100 to the base 10 is equal to 2. That's what this statement is meaning. Likewise, if you have any other number, for example, we know about 27. 27 is, I think, 3 power 3 is equal to 27. So we are saying for 3 to be equal to 27, we must raise it to the power 3. The meaning is that the logarithm of 27 to the base 3 is actually 3. So this one here becomes the power to which the number should be raised if it is to be equal to the given quantity n. That is very important to note. So sometimes we are saying logarithm is just a power. So we can either call it a power, we can call it an index, we can call it an exponent. Exponents. All those words mean the same. This one can be 3 exponent 3, or 3 power 3, or 3 to the index 3. So any of those 3 words will be meaning the same. Okay. Have we written that statement? Please rewrite it for purposes of revision. Write that statement. Can we continue? Are we done writing this?
Yes, teacher. Yes.
I want to look at the laws or theorems or properties of logarithms. Laws of logarithms. Laws of logarithms. Laws of logarithms. Law number one. I don't know if I should be putting the statement. Maybe. The law is the unity. Unity and a base is 0. What does this statement mean? If I'm to put it in mathematical statement, means that the logarithm of 1, irrespective of what base, whether the base is 1,000, whether it is 10,000, whether it is what, this one will always be equal to 0. So the logarithm of 1 is always 0. You can check this on the calculator. Now, the logarithm you have on the calculator is the base 10. The calculator is made so that the logarithm on it is actually to base 10. So when you press log and then 1, you are meaning log. You are meaning log of 1 to base 10. Does it give 0? Those who have calculators near them, what is log? Press log and then 1 and equal sign. Does it bring 0?
Yes, teacher.
Very good. So how do we prove this one? Proof. Now, in our definition, we say by definition, A, our x is equal to n. The general statement, whatever the value of n, whatever the value of a, whatever the value of x. Let me write it very well as x. Now, for x equal to 0, what will this one be meaning? We mean that a, our 0, is equal to what will be the value of n?
One.
It will be 1. Remember from indices, we said any number to the power 0 is always 1. So whatever value of a, once the power is 0, the answer becomes 1, and we proved that one. Now, if this one is true, can we write it in the logarithmic method, which we have just been talking about here, where we are saying if I have 10 power 2 is equal to 100, we are saying this means that the logarithm of 100 to base 10 is 2. We said this one is the logarithm of 100 to base 10 is 2. And we do the same with this one. Now, instead of having 10 power 2, I have a power 0. Instead of having 100, I'm having 1. What will it be, therefore? From definition of logarithm.
Log 1. Log base 8 to the power 1 is equal to 0.
Log 1 to the base 8 is equal to 0. Is that untrue? What is the base? This side remains the base of the log. See here, the base is 10. It remains the base of the log. And what was the power goes to the other side of the equal signs. So what was the power? The 0 will be the other side of the equal signs. And what was on this side, the 100, is the one which comes here. So the one that was across the equal signs is the one which will be here. So logarithm of a, the logarithm of 1 to base a is 0. Do we agree with that one?
Yes, teacher.
And that is the proof for this. It's called law number one, or theorem number one of logarithms. It's important that wherever you find, even if they write log of 1,000, of 1,000,000, as long as it is the logarithm of 1, irrespective of what base, the answer will always be 0. That one needs to be in our heads at all times. Okay? So I hope probably we need to write that one. Need to write that one, I guess. Because we can ask you to prove that log of 1 to any base is 0. Just a few statements there. We continue. Are we done with that?
Yes.
No, number 2. No, number 2. Number 2 says the logarithm logarithm of a number, the same base. The same base is 1. What do we mean? If I want the logarithm of a, when the base itself is a, then the answer will be 1. What e.g. supposing I say the logarithm of 10, when the base itself is 10, we are saying this one will always be equal to 1. Why? If I have 10 and I raise it to the base 1, now I mean to the power 1, isn't the answer still 10?
Yes.
So as long as the base and the number itself are the same, the answer will always be equal to 1. So wherever you find, whether we write log 3 or 3, the answer will always be 1. We can prove this, just like we proved the earlier. Proof. If a or x is equal to n, for x is equal to 1, a power 1 will be equal to, what does the n become if a is power 1? Becky?
It becomes a.
Becomes a, because any number to power 1 is that very number. Any number to the power 1 is that very number. Just a moment. So we have agreed that any number to the power 1 remains that number. Now, can we write this number in the format we wrote earlier, where we said, for example, 10 power 2 is 100, and we ended up with saying, it means the logarithm of 100, the base 10 is 2. And we express this one in this format. It is already in this format. This is in the format of this. Can we therefore write it in terms of logarithms? You said you write logarithm
Log x plus
a base a
is equals to 1.
this one. We call it the second theorem or the second law of logarithms. But it's as simple as that one. Can you imagine? We copy that one and we go to law number 3. We proceed.
Yes.
Law 3. It is important to understand these laws because just like with the indices, no question is going to tell you using the second law, using the first law, or what. No. It is you to judge. When you see it, you say, I think here I have to apply the other one. So that's why I'm being a bit slow, because we need to grasp very well these laws. When you start applying them, you don't say, now, how did we come to choose this law? Just a moment. Number 3. Number 3 says, if I have a to the power of log, this time the log is the power itself. A power of n, but this one is equal to n. So log n base a is the power now, the whole of it is the power a. And this one will be equal to n. And you can prove this one. And we prove this from our definition, a power x is equal to n. Actually, what we can do is to first let this power here, since it is complex, first let it be something simple. Let a power n b equal to x. Means that if I have to rewrite this expression, it's going to be a, where there is log a power n, I mean log n of base a, I'll write there x. So I'll write this one as x is equal to n. Do you understand that step?
Yes, teacher.
I'm letting the complex power. The power is the log a, I mean log n to base a. So I'm letting the whole of that power be equal to x. Meaning that if I rewrite this statement, where there is the whole of this power, I can replace it with the x because I have let the x stand for all that. So it will now become a power x is equal to n. Which if I write it in terms of logarithms, this one, how can we express it in terms of logarithms? This one means that the log
Log base a.
of n base a, not so?
Yes,
Is equal to
equals to x.
is equal to x. Is equal to what? Is equal to x. Actually, what else do we need? I think it is even coming out from here. Let's see. Besides a to the power that said let log a of n. What did we write earlier? Log a of n is equal to therefore this one is equal to this. We're saying let a n be equal to x. Implying that x power a. I think it's even out directly, even if we don't add even this statement. Say if we let this one be just some power x, then the statement will be written as log, or I mean a power x is equal to n. In which case a power x, this one alone, is already equal to what? N. I don't know if it is coming out properly with the everyone. Because when I put the x here, a power x, this one, the whole of this left-hand side is exactly what is here. And then is equal to n, which is the other side. Is there any other way we can explain this? I think the kind of direct. There's no big proof we can do here. Now, this law can be further expanded. But I think in the interest of time, I think we have to just start from here. We don't surpass our time. When we come back, we shall do more on the third law, and we continue with the fourth, the fifth, up to number 7. So we still have many to prove. And then we can start doing exercises, including or involving logarithms, okay? Now I want to wish you a nice lunch. When we come back, we'll look at all the other laws, and then we start on examples. I want to wish you a nice lunch. Alaikum salam. All right.
Thanks.
And I say bye, each and everyone.
Nice lunch too.
Right.
Nice lunch, teacher. Thank you for teaching.
Welcome.